Hi everyone, my name is Kundan Sarma. Today I am here to do numericals on work energy, which is chapter 7 of my physics 221 class. Here we are given a metal mass of 3 kilogram and is moving down with a speed of 2 meter per second. Let's look at that in a diagram. There is a mass of 2 kilogram which is moving down with speed 2 meter per second, and it hits right on the spring, which is of length 0.4 meters, and its stiffness is given to be 2000 Newton per meter, and when the block is moving, it is 0.8 meters above the ground. So the first question is telling us the block continues downwards, compressing the spring. So when the bottom of the block is 0.3 meters above the floor, which means that the spring is compressed 0.1 meter, since the spring was initially of 0.4 meters. So what is the speed of the block? And the second question is telling us the block eventually heads back upward and loses contact with the spring and continues moving upward. So what is the maximum height reached by the bottom of the block above the floor? So first, let's solve first question. Here our system would be earth, block and spring, and using the energy principle we know that final energy would be equals to sum of initial energy plus work done, and final energy would be equals to final kinetic energy of the mass plus the final potential energy stored in a spring plus final potential energy of the mass, which is equals to initial kinetic energy of the mass, which is the block, plus initial potential energy stored in the spring plus initial potential energy of the block plus work done by the system. Yeah, W shows work done by the system. So yes, since the spring is not in contact with the block, work done by the system would be zero, and the potential energy initially stored in a spring would be also be equals to zero. So K of F would be half mv of F square, where F indicates final, and the potential energy stored in the spring would be mgy of R. The potential energy stored in a spring would be equals to half K S square, and the F indicates the final. So Ks of square, and UGF indicates the potential energy of the final potential energy of the block, which is mgy of F, and this would be equals to mgy of I, which is the initial potential energy of the mass, plus half mvi of square, which is the initial kinetic energy of the mass. So here v of f is the value we want to find. So doing the algebra, we get v of f to be v of f square to be v of I square plus 2g yi minus yf minus k of s over m times s of f whole square, where v1 is the initial speed, which is 2 meters, 2z, where z is gravitation, acceleration due to gravity, times yi minus yf, this is the initial position of the block, which is 0.8 meters, and this is the final position, which is 0.3 meters above the ground, minus k of s, which is the uh, stiffness of the spring, over which is m, which is mass of the block, and s of f, which is the compressed length of the spring. So v of, when taking the square root of right hand side, we get the v of f, and plugging in the value, we get the equation like this. And here the final velocity v of f would be 2.7 meter per second. So the velocity of the mass, when velocity of the mass of block when it was 0.3 meters above the ground, is 2.7 meter per second. Now the second question is asking us to find the maximum height. So what it says is that it is no longer, mass is no longer with contact with the spring. So using energy principle, we again use the same formula. Final energy would be equal to sum of initial energy plus work done by the system, and final energy is final kinetic energy of the block plus the final potential energy stored in the spring plus final potential energy of the mass, which is equal to initial kinetic energy of the block plus initial kinetic energy stored in the spring plus initial potential, this usi indicates initial, and which is the initial potential energy of the spring plus ug of I indicates the initial potential energy of the mass plus w, which is the work done by the system. Since the mass is no longer contact with the spring, the initial potential energy of the spring plus initial potential of the spring, final potential of the spring, and work done by the system would be equals to 0. And since we are given to find maximum height, at maximum height velocity would be 0, so final kinetic energy would be 0. So what we are left with is the final potential energy would be equals to initial potential energy plus initial kinetic energy. So mgy of f is equals to mgy of I, final potential energy and initial potential energy, plus half mvi square, which is initial kinetic energy. So doing algebra, we get yf is the value we want to find, which is the maximum height, so which would be equals to yi plus v of I square over 2z, and we get that to be y of I is the initial height, which is 0.8 meters, initial velocity 2 meter per second square times 2 into 9.8, we get that to be 1 meter. Therefore the maximum height reached by the block is 1 meter. Thank you, that's it.